Hi everyone, this is Aurelien. I'm working for Bloomberg here in Tokyo, and I'm gonna tell the story of my first contribution to Clang, how I implemented attribute reflection by piecing together a bunch of small hacks. Yeah, basically share what I learned along the way. Hopefully nudge people who are afraid to contribute in the good direction. So if we cross our fingers hard enough in C++26, we're going to get reflection. And reflection in the original proposal cover a lot of the existing grammar. Our work, though, focus on extending reflection to support reflecting over attributes as well. And so you can finally write this thingy on the bottom left so I guess for broader context, reflection comes along with two new operators to go back and forth between the value and the grammatical domain. At this stage, basically all you need for your proposal is to talk to people. They will tell you it's a terrible idea, but then you still do it anyway. Right, so after a while, here's my, I guess, mental model for what happened to, or at least with C++ attribute in Clang. So in places where it makes sense for attributes to show up, parser goes through the attribute token, it goes through the arguments, and from there it builds a generic parsed attribute. Syntactic attribute at this point. Sema inspect the particular kind of attribute that it is, and then a semantic representation of that attribute is constructed, the so-called ATTR at this point. Finally, that semantic attribute is attached to a node in the AST, and meanwhile, the original parsed ATTR is dropped. I guess the stepping stone for me here is when you put together how the whole codegen machinery works, how the actual specification for each attribute is written in the SL in this attr.td file. Also for me at this stage is why I started to obsess over attributes, and I started to take it personally when people start to say we can ignore attributes. So that might happen to you as well. Next, right, so I think the first challenge for me popped up because reflection kind of blurred the line between, or at least I think, between sema and parse. So in this thing on the left, the sample, you have attributes of which query foo's attributes. But what you get back from this whole thing is the semantic representation for those attributes. Me at this point couldn't figure out an easy way to get back the syntactic attributes, which expose arguments. I only have the semantic one. They don't expose a easy interface to get back those things. I really do want those arguments, though, to be able to synthesize back a attribute. So introducing the first hack. So the first step is to extend the lifetime of our syntactic attribute so that it survives past the parse phase. Then we embed a pointer to that syntactic representation inside our final ATTR object. And so now we can basically just navigate the chain from a decall to an ATTR to the parsed ATTR to your arguments. Here, my take is that when you're learning something completely new and it's not something that's trivial, you should be really kind to yourself. Just make it work first. You can always come back later, clean it up, refine, rework on it. Right, so dependent expression showing up in places where we don't really expect them to. So here in that kind of vanilla example, we have to delay the evaluation of this #t showing up inside that splice expression. And we have to delay it until we know what t is, which is basically when we instantiate that template. So this is not a new problem. In C++, people already kind of worked out the solution to all of those things. in a lot of different contexts. This is probably what tree transform is supposed to be doing. However, if you're not very familiar with this whole thing, you don't know if that's really the thing that you're looking for, and then even if that's the thing you're looking for, you don't know how long it would take you to make it work. So introducing the second tactical workaround. So we go back to this file I talked before, this attr.td file, and we create or we add a custom attribute. That custom attribute takes an expression as an argument. When we pass the template, which is the thing here, when we pass the template, we synthesize that custom attribute and we stash that unevaluated expression inside it, and we attach that thing to the template in the AST. Later on, hooking into that lovely function, instantiate attr, you can just look around and see if you're finding this custom attributes. Then you can get back that argument, evaluate that whole thing, and you know what entity you're looking at for the attributes. So that's this whole thing. Actually, the last step is to recompile Clang and just wait for hours. So lesson here. I think sometimes this kind of shenanigan is kind of the best, like that's the only thing you can do basically to unlock you. And that's okay if that's what will make you progress. I think doing those unlocks some of the understanding that you're going to need anyway to graduate to the better way of solving things. So don't judge yourself too harshly if you have to write stuff like this. Finally, my most technical slide. Thank you all. I'll be hanging around if you want to discuss that whole thing. Thank you.